はい、皆さんおはようございます。本日はこのように皆さんの前にお話しできることは大変光栄で思っております。実は登壇が決めた直前だったのですが、このように貴重な機会は腐った主催者とスタッフの皆さん、心より感謝申し上げます。まず自己紹介させてください。僕はアンソニーと申します。ViewNox のコアメンバーとして活動しており、VTest、Live Type Challenges、UNO-CSS、ViewUse などオープンソースプロジェクトも作りました。また ESLint スタイリスティック式2/のメンテナーもしています。今、NUXLab で働いています。僕のウェブサイト ANTFU.me や GitHub で見つけられますし、日本語用の Twitter アカウント ANTFUJP もあります。僕は2ヶ月前にパリから東京に引っ越してきました。そのことについては僕のブログも書いてあります。今日本語の勉強中でここまでは僕の日本語の限界です。なのでここから英語で話させていただきます。いつか全て日本語で講演できるように努力してまいります。皆さんよろしくお願いします。Okay. I'm sorry, I have to speak English because I'm probably maybe the next time I'll try. So for today, I'd like to talk about. Oh yeah, just to check, you should have the translations, right? I don't know where you have the translations. 翻訳のことが大丈夫ですか？皆さん大丈夫？はい、大丈夫ですか？はい。So okay. So for today, I'd like to talk about the new ESLint config. So what you can do with it and how you can get type safety with a good developer experience and for your configuration. So almost 12 years since ESLint came out, at this moment, it's easily one of the most popular tools in JavaScript ecosystem that almost every project uses. Despite that it has been around for such a long time, it's a tool that's still consistently improving and evolving. So before we start, I'd like to do a quick survey here. If you have heard about the new ESLint flag config, could you raise your hand for me? フラッグコンフィグ知っていますか？手を挙げてください。はい、ありがとうございます。how many of you are using flag config? すごい。Okay, thank you. So actually, it's a lot than I expected. Okay, so thank you so much. So so you probably know that ESLint version 9.1, 9.0 was actually released over a years ago. So this is a live component, so it calculates the time. So the main highlight of this major version is the rolling out of new configuration system. It's called flag config. And there's a blog post on their website to explain the motivations and the design for their new config system. So just right at the time, yesterday, they also released a new post to review this year since the release, to see what they do right and what they are not doing well, something like that. So if you're interested, please do check it out. Okay, so in case you have never heard about this or haven't dig into the docs here I'd like to do a quick comparison between the legacy ESLint RC config and the new flag config for you. So to differentiate between those two configuration formats is rather straightforward. The legacy config is named with .ESLint RC, or it supports multiple extensions. And it can also read from your package.json with ESLint config attribute. And in the flag config, on the other hand, it's only load from ESLint.config.js file, a JavaScript config file with a single source of truth. And also, of course, they recently add TypeScript support so that you can now use ESLint.config.ts. So when it comes to reusing the shared config, the legacy config formats implicitly use the convention-based extend properties to load the config from your node modules. So as you can see on the left, so you have to know a little bit like how the convention works to know what exactly it's going to resolve. So while that's on the other hand, like in the flag config, you directly use the explicit import, and then you provide the config directly. So then you have more control. And for plugins, it uses an array of strings, so which once again is a convention. So you have to know that, for example, like plugin view is going to resolve to ESLint plugin view that package. And on the other hand, like for the flag config is a name object for plugins, which means now you can rename the plugins easily or switch to a fork without being too forced to change every rule if you have a different package. So, and also the inherent nature of extend might result a very complex tree structure in the shared config that you have. You may have like nested extend inside or something. So in the flag config, it's simplified a lot. So basically, you import shared config as multiple objects or array, and you compose them as a single flat array. That's why it's called flag config. And finally, the legacy config is usually a JSON, which is very hard to do type checking. While the flag config is now a JSON file, and it also supports TypeScript, so which means it will be a lot easier to ensure the type safety. So for a little bit more context here, so here is a graph that I draw to demonstrate the timeline. While the flag config might sound quite new to some of you, it's actually already been planned for 5 years already before it's rolling out. So the first RFC was created in January 2019, and the first implementation is available in V8 12.1 as experimental, and well, that was already 3 years ago. And it becomes stable in version 8.45, and then it becomes a new default in version 9.0. So in between, ESLint's team has published multiple blog posts to kind of explain the reason why they want to introduce the new config and to share the roadmap of rolling it out. So that's a lot of effort like across this like 5-year plan. So I have like huge respect to the ESLint team. So in version 9.10, ESLint ships the official type definitions, which means you don't need to install the type/ESLint anymore. And in version V9.18, it also supports TypeScript config out of the box. So as we mentioned before. So before we talk about the new exciting stuff, let me introduce you the tool for migrating your legacy config to the new config in case you might need it. So there's an official CLI called ESLint/migrate config that automatically converts your legacy config file to the flag config. So during that process, some runtime compatibility tools will be introduced automatically along the way. And then like you can migrate to flag config first, and then you gradually replace those runtime utilities with a more modern flag config. So I would recommend you to check the ESLint docs and the migration guide for more detailed instructions. So let's talk about the new interesting tools and the possibilities enabled by this new format. So the first one is the ESLint config inspector. So it's a visualized dev tool that allows you to inspect and play with your final result config. So the first thing it does is to render each config items you might have. So sometimes you import some shared config into your config, so you don't know what exactly it is. So you can see all the config listed here. And here I have like a rather complex setup here. But with the name provided by each config, you can easily understand like what's the purpose of each of them. So, so you can expand each item to see how it contributes to the final config. Like for example here, so I have like JavaScript setup. So you can see the configuration for that, and also you have the rules. The rules are enabled for my project, and you can click into to see like what's the configuration for it, like how I enable it. It's marked as error, and you can have a like short description for it, or you have like a docs link directly jump to the correct documentation page for that specific rule. Yeah, and so since in ESLint, sometimes it's hard to know which files or which rules which are actually enabled. So here we also have like a file tester. So for example, like I can type package.json. So then I can see like for that package.json file, which rules are applied to these things. For example, here, like we have like JSON-C rules that applies to every JSON file. So I can see why it's being introduced to that specific file, what rules are enabled. And here I have like very specific rule for linting package.json that's it can like sort like keys. So maybe like every time I save my package.json, it will sort as the order I want. Like that, just for example, like that. So you can also like change to like TS. TS, I don't have it yet, but like for example, like JS, why it's enabled, why it's disabled, or something like that. And then you also have another tab called rules. That is all the rules enabled, available in your project. So here I'm selecting using, and here is all the plugins I have. So for example, I can see this, or I can like unuse import, or like for example, we have like maybe YAML files. And then this is all the rules are enabled. I can also see like what's the rules are available but I'm not using. Or is there any recommended rules I'm not using? Like for example, like in ESLint, those are recommended rules, but I didn't enable it in my project. So you can have like a better insight of what rules you enable for your project, something like that. And okay. And here is actually the config file, the config preset as an example that's showing on your, you can see it on the right. So you see like this is like this is my shared config, and it's a function that takes arguments. And wait a minute, okay. So, and you can see it takes a little bit weird like options, right? So I disable TypeScript here, but like it makes no sense for TSKaigi to disable TypeScript, so let's enable it. So if I type true, and when I save it, so you can see like on the right, there's like TypeScript rules pop up. So this is like the types rules. It disable the JavaScript rules, enable the TypeScript rules, something like that. So, and then I can also change the indentation if I don't like it. I want to like for, or like I want tab. So I wouldn't argue that. And then also like it can change a little bit more. Like for example, like have a TypeScript here. If I want to enable type aware rules, I change this to an object. I probably need to hit. Okay, so I can provide like tsconfig path, and then I have tsconfig .json. Yeah, when I save it, so you can see it now enables type-aware rules with the proper configurations I need, and those are type-aware rules that's like no return await, something like that. So that's like a quick demonstration of this ESLint config inspector. So if you're interested, you can give a try in your own project to see. Okay, so and here let's do a quick comparison. That's to see what's the new capability of the new flag config. So in the new flag config, a shared config can be actually a factory function, as we showed before, that takes user options, and the user option you can define them. So which we couldn't do it in the legacy config. So imagine if I want my config to work for both TypeScript and non-TypeScript project, view and non-view project. You can see on the left, that's usually how I should do it. I should create a monorepo that's publish config for different combination. So I have a basic ESLint config, and for TypeScript, I have ESLint config-ts. So as you can see, it doesn't really scale well. So like I basically doubling the amount for each combination, for each configuration, because usually a preset couldn't take options. So if I want to have like a React, I basically make 4 config into 8. So every option that I add is basically a new combination, so which is not ideal. But with the flat config, it allows you to provide semantic options to toggle each features dynamically. So making one single config able to adapt to different projects. And also, since it's just a JavaScript file, so you can provide types and JS stock in your config, making it type safety or like self-documented. So because of flexibility, we could also have high-level abstractions to absorb the underlying complexity. So if you have ever like make a legacy ESLint config yourself, you probably feel that it's so complex, it's so many rules and something like that. But as a user, we don't want the user to worry about those things. So with the new possibilities, we can have a minimum configuration interface like prettier, while the end users doesn't need to worry about underlying details, but still have the full controls when you really want it. So basically, I would say that it's a simple configuration like prettier, but it's powerful and flexible like ESLint. Okay, yeah, and to introduce some tools I use to make the config customization easier. I also made a small library called ESLint flat config utils. So for example, here is a flat config I might have, and depends on how each shared config it is. Like for example, I import the config from TypeScript ESLint, and and the others. So some are exporting a plain object, and some are exporting an array, and some might even have like constructor that returns an object or something. So when we put them together, it's usually your responsibility to check if it's an array or if it's an object or array. If it's an array, you need to like use REST to expand it. But with the config utilities, I made the function called compose, which would automatically resolve all different types of the configuration. So it means that you can put anything, even it's a promise, even it's an array, it'll automatically merge and flat them. And it also provides some like chainable actions where you can like insert extra configurations or override some configurations or like some rules to handle the merge manually. So it gives you the more flexibility. And then thanks to the flexibility of like the ESLint config, the flat config is a JavaScript file, and also it has the full context available in the config. So it makes the type generation actually possible. So I made another tool called ESLint type gen, and as you can see here, it's just like depends on what the plugins are installed. It will generate a local DTS file based on all the plugins you have installed. And it provides autocomplete and type check for all the rules you're using. So here is a screenshot. You can see like I may have the indentations, which expecting a number too, but I put a string, so I had an arrow, or I got auto-completions based on like how many rules available. So underlying these tools, so how it works is basically, so is that too dark? A little bit. So it takes the entire config array and passes through. So the function does nothing at the runtime, but it traverses all the configuration to get a plugin instance. And from the plugin instance, we can get all the rules available and to retrieve the JSON schema for each rules it defines. And we use JSON schema to TypeScript, this package, to generate the types. And then we save it back to typegen.dts file, like the code on the right. So it will be like a lot longer based on the plugins you have installed. So the DTS file will argument back to ESLint. So that's you got auto completion, you got all the types from it. So with that, we got a more accurate type for all the plugins without the need for plugins to actually adapt to TypeScript or anything. So it works for any plugins, even like with JavaScript plugins or legacy ones. Okay, I hope that makes sense. And okay, so another topic I would like to bring up today is the fact that ESLint is more than a linter. So to me, I see ESLint as a mature and powerful AST toolkit that has a large ecosystem on its back. So I would like to say that ESLint can be a formatter. So it's certainly not new, as many projects have already been using ESLint that way since the very beginning. But last year, ESLint and TypeScript ESLint team decided to deprecate those stylistic rules from the core due to the maintenance effort. So then I initiated the ESLint stylistic project. It's gathering all the stylistic rules for JavaScript, TypeScript, and JSX into a single organization and make a community to keep maintaining them. As I see, like ESLint as a formatter is much more flexible and customizable than Prettier due to ESLint's pluggable nature. So if you're using VS Code, you can have editor code action unsafe to auto-fix the ESLint errors unsafe. And also you can have an interesting rule called ESLint rules customizations to actually silence those specific rules based on your configuration. So with the indentation, you no longer get like red lines, squares or lines underneath, but like when you save it, it's still like formatting you. So it behaves more like a linter. So you can, like for example, we can silence all the stylistic rules in the IDE, but we still get all the benefit from auto fixing. So I guess that there will be similar option for the other code editors if you are not using VS Code. Okay. And then a rule in ESLint, like a linter rule in ESLint, is actually essentially a function that take code and AST, and then you basically reporting errors and with optional fix information. That means ESLint can also be a nice tool for Codemod. Codemod means like code modifications. So for example, I made this like ESLint plugin command to do on-demand microcode mode. So I can show you this video. So as you can see in this video, like I can put like magic comments before an arrow function, like I can put two functions, and when I save it, the linter will automatically convert it to a function declarations. And similarly, I can also have a keep sorted. So every time, so only for that specific object. So every time I change the orders, when I save it, it's automatically sorting it. And similarly, I can also have a keep unique. So I can, even with an array, I can also always keep the value of the arrays unique. And I can also like hoist the regex to move regex from the functions to the top level. So every time when I call the functions, I don't need to initiate the regex again. Or I can have like a if else to ternary. So when I save it, it automatically saves to the ternary mark, or vice versa actually. And then you can have like two string literals to expand the string template to like no more options, something like that. So that's like some example of it. So so this like ESLint plugin command is actually kind of like some like basic abstractions to make these things easier. So if you know a little bit about AST, or it shouldn't be hard for you to write like this one-off Codemod rules, like those micro Codemod rules to migrate your code base as well. So I don't know what's the use case of it. So I would like to inspire you if you have like more ideas. Maybe you can do like change all the, like for example, we have like change all the types to interface, and you can also do that as well. So I just want to like throw out this idea. And then finally, I'd like to mention like ESLint can also be a linter for other languages other than JavaScript. So technically it's saying TypeScript is actually another language that ESLint doesn't support, right? So then we have TypeScript ESLint tool plugins to kind of parsing TypeScript and for fitting into ESLint. So, and then we have a lot of plugins to also link Vue, Svelte, Astro, JSON, YAML, GraphQL, HTML, MDX, and a lot more. As you can see here, like thanks to those maintainers, and it's not an exclusive list for sure. And so you can also check the ESLint's RFC number 99. That's they are trying to make ESLint more agnostic. So you can already see some effort. I think I forgot to put it here, but they now have an official Markdown plugins, and official CSS plugins, so that you can actually linking CSS with ESLint. So I think they are looking for more rules. So if you want to contribute, I think that could be a good chance to get into open source if you are interested. And okay, so to summarize today's topic, I would like to say that ESLints make it possible to be like one for all in two aspects. So you can have one config for all the projects that can adapt to different needs. And also you can have one tool for everything related to code checking and modifications. Okay, so if you want to learn more, you can check my personal ESLint config, where I use all the tricks I mentioned today. I'm honestly a little bit flattered to see, like, even though I didn't intend to have this config to be used by the others, it's ended up to be quite popular and has like 5,000 stars and over 30,000 projects using it on GitHub. So, I mean, I wasn't trying to convince you to use my config, but hopefully it can be a good reference for you to build your own shared tools for yourself or for your teams. So to provide both powerful and flexible, and of course, with the type safety. So, so another topic. So I bet like you must be questioned like until now. So we have, if we talk about the future of linting, so I bet you might ask like, what about the new uprising native linters like BioLint, OXLint, or DinoLint? So my quick take is like they're already usable in many scenarios, but they're not yet ready for like majority. So the advantage of native linters are obvious. They are faster, and for tools like Bio and OXLint, they provide unified toolchain for formatting, linting, and bundling, etc. And since native languages can also leverage like multi-threading, this would also mean that it would be more efficient and more faster to link multiple files at the same time, etc. But on the other hand, I would say like the current limitation is like they are not very extensible. And their lack of the like powerful plugin systems and the like rich ecosystem, but I mean it takes time, and it seems like since the parser are implemented in native language, so most of them are currently only support JavaScript and TypeScript only. Like for example, for the other language for Markdown, for CSS, they require an entire new parser in their language. So it's pretty limited in terms of like if we want to linting for many languages. And it's like, for example, like language like Vue or Svelte, it could be hard for them to link it well, like to match the feature parity as ESLint. So and then right now they usually requires a static JSON config format, which is more like the legacy ESLint config we had. Then we don't have those great flexibility that we mentioned today. So so what I'm seeing is just like it still takes time, and it's actually right now at this moment, I think it's good like you can have this tool working together, so you can have ESLint to handle the part that native linter tools couldn't handle. But ideally, I think my take is that native linters are very valuable and additions to the ecosystem. But before they reach feature parity with ESLint, I think they can coexist for quite a while. And I think for better integrations, I expect that either ESLint can be integrated into native linter or vice versa, like having native linters APIs in ESLint or something during this transition period. And also, since type-aware linting is one of the biggest bottleneck in terms of the performance, with the new TSKaigi compiler, and they just released it yesterday, is also impressive. I hope it can help the native linter to maintain a good performance, even with type-aware linting. I know, like in the schedule, we have many talks to talk about those linters, the plugin systems, and also TSKaigi. So, yeah. So please do check them later. So then finally, I'm actually working with the OXLint team to explore, to see like how we can do a better integration, so like user can get the best of both worlds with a great performance and fully flexibility. So in that case, please stay in turn. All right, so that's all for my talk. So you can find my slides at my website. So ありがとうございます。じゃこの後のカンファレンスを楽しみください。ありがとうございます。